Okay, so any two masses, M and M, attract each other. This is the law of universal gravitation. They attract each other equally. We have two forces, F1 and F2. And according to Newton's third law, these two forces are always the same, all right? So the two masses, any two masses, attract each other with equal forces, and these forces are given by the formula that includes the two masses, the distance between their centers squared, and this nice big G, which is the universal constant, which is 6.67 times 10 to the negative 11th newtons meter squared per kilogram squared. Why does this constant have a units? Because in this formula we have kilograms for masses, we have meters for distance, and we need to find newtons. And to do so, we included in the constant these units, so we come up with a result having newtons as the unit, right? So this is the formula according to Newton's gravitational universal gravitation, and we see that these forces are proportional to the masses and inversely proportional to the distance, meaning that if one of the masses doubles, the forces will double. If both masses double, the forces will be 4 times stronger. And we can prove that. Let's prove it. All right, so we have two masses, M and M at a distance R, and we do know that the forces are equal to this. Now, let's say that we double this mass, this becomes 2 times M. This stays as it is, and of course the distance stays as it is. The new force, F nu, will be G, the universal constant, times the one mass, which is 2m now, times the other mass over their distance squared. Okay? So we will use proportionalities again and again to find how the forces change if something changes here. And then we said that we can actually have two methods. The one is the substitution and the other one is the proportionality. Substitution means taking the new force and put the numbers outside the formula. And seeing that what is left is actually the old force. And substituting this with the old force, and we see that the new force is 2 times the old force. Now, that's the substitution method. The proportionality method, using the proportionality means to divide these two and say, okay, if the new force over the old force equals G 2m n over r squared over G m over r squared, we can get rid of the G, and what we can do is multiply the outer sides of the complex fraction and make it the numerator. So the numerator will be 2m r squared, 2m times r squared, while the denominator will be r squared, r squared, and we can see that we can get rid of everything besides 2, meaning that the new force will be 2 times higher than the old force. So either the method of substitution or proportionality give us the same results. Now, which one is easier? Well, I think it depends on the problems. This is too easy, and substitution works fine. But in other cases, when it's hard, I personally prefer the dividing them. Now you have to remember that the outer parts give you the numerator, the inner parts give you the denominator. All right.